I want you to picture a scenario right at the start of your morning commute.
Well, best time of day for things to go wrong.
Exactly. So you slide into the beautifully minimalist, Zen-inspired cabin of your brand new Japanese electric crossover.
Right.
You ready to tackle the day? But there is a catch.
There always is.
Yeah. The sleek, futuristic wooden dashboard simply ignores your existence.
Just completely ghosted by your own car.
Completely. You tap it, nothing happens. And the moment you finally, get the heater to turn on, your estimated driving range instantly drops by 40 miles.
It's brutal.
Welcome to the chaotic daily reality of software gremlins.
It is a fascinating paradox, really, that we are seeing across the entire industry right now.
Yeah.
You have this incredible, century-refined physical hardware, but it is entirely held hostage by a hyper-conservative digital brain.
Right. The software is terrified.
Exactly. We're watching legacy automakers try to become software companies in real time.
Mm-hmm.
And the growing pains, they are vast.
And that transition is exactly our mission for today's deep dive. We are exploring the bizarre clash between the visually stunning physical design of the Nissan Ariya and its, frankly, deeply flawed digital architecture.
It is a perfect case study.
It really is. But before we unpack this beautiful mess, if you are enjoying our deep dives, or, if you've ever found yourself fighting your own car's software, take a second right now to subscribe to the channel.
Please do.
Like this content and leave us a comment down below. It seriously helps us keep bringing you these deep dives.
It definitely does. And getting back to the vehicle, it perfectly highlights the friction between mechanical engineering, which is highly deterministic.
Like a gear turns, a wheel spins.
Right. And software engineering, which is probabilistic. We expect cars to behave like light switches. You flip it, it turns on.
Yeah, but modern EVs are constantly guessing what you might do next.
And usually guessing wrong.
Right. So let's start right at the center of that friction, literally in the middle of the cabin.
The dashboard.
Yes. The interior design of this car was highly publicized, and based on the data I have here, it relies heavily on capacitive touch haptic feedback buttons.
Which is a bold choice.
And the catch is that they are physically embedded directly into the faux wood trim.
Now, from a purely aesthetic standpoint, I have to support the designers here. It is a brilliant design choice.
Oh, it looks gorgeous.
If you are standing on a brightly lit showroom floor, it feels like something out of a concept car.
Yeah.
There are no clunky plastic knobs breaking up those clean, sweeping lines. It visually communicates this incredible sense of calm.
Sure, it communicates calm in a climate-controlled showroom, but in the real world, this specific user interface is incredibly frustrating.
The environment ruins the illusion.
Completely. The telemetry data we're looking at shows these digitizers are highly susceptible to environmental factors and just severe processing lag.
That is the inherent trade-off with capacitive touch, especially when it is layered beneath a secondary material like simulated wood.
Because it's trying to read through the material, right?
Right. Exactly. Capacitive sensors work by measuring the minute electrical charge of your finger.
Right.
When the internal cabin temperature spikes during a blazing summer afternoon, or, say, drops significantly during a humid winter storm, the sensitive digitizer just struggles to register that electrical capacitance.
So the physical environment literally alters the signal the sensor's trying to read.
The sensor is blind, essentially.
Which leads to a scenario that is practically a rite of passage for owners.
The tapping.
The aggressive tapping. You're driving along, you're a little too warm, so you start tapping the wooden dashboard to turn down the climate control fan speed.
And nothing.
You tap it once. Nothing. So naturally, you tap it 5 or 6 more times. Still absolutely nothing.
The system hasn't actually ignored you, though. It is just severely delayed.
Right. So right when you finally give up and accept your sweaty fate, the central processor suddenly catches up.
It processes the cue.
It registers every single one of those frustrated taps all at once and just violently blasts freezing cold air directly into your face.
It is a delayed reaction of the worst kind.
It's like the dashboard has a dial-up modem hidden behind the wood.
While it sounds like a minor annoyance, from a software architecture perspective, it actually tells us a lot about the system.
It tells me it's broken.
Well, it indicates the main infotainment system is running on a poorly optimized operating system. The processor is bottlenecked.
So it knows I tapped it.
Yes, it is queuing up your physical inputs, but it lacks the processing priority to execute them in real time because it is bogged down by background tasks.
And that processing bottleneck is not just limited to the climate button. It infects the dual 12.3-inch digital displays that completely dominate the front cabin.
The screens are a whole other issue.
The owner logs detailed scenarios that go far beyond a cold blast of air. Imagine you are relying on the wireless smartphone mirroring to guide you through a really complex highway interchange.
Heavy traffic, usually.
Exactly, bumper to bumper. And suddenly, the entire screen just dies and goes totally pitch black.
That is the operating system encountering a fatal memory leak.
Which is terrifying.
It is forcing a hard reset to save itself.
But wait, why does a car need a forced reboot while moving? If my laptop crashes, it's annoying.
Yep.
But if I am flying blind in heavy traffic in a 6,000-pound vehicle because the navigation and vital readouts just vanished, that is a massive hazard. How did automotive engineers let that slide?
I will play devil's advocate here because the engineering challenge is genuinely immense.
Okay, defend the blank screen.
These systems are managing a staggering amount of data simultaneously.
Sure.
They're rendering 3D maps, managing wireless communication protocols with your phone, monitoring high-voltage vehicle telemetry, and running background diagnostics all at once.
That is a lot of data.
When the memory overloads, a forced reboot is the system's absolute only way to prevent a total bricking of the hardware. It is a self-preservation mechanism.
So it's protecting itself, not me.
In a way, yes. The car prioritizes keeping the drivetrain active over keeping the navigation display alive.
That makes sense technically, I guess, but it's a terrible user experience.
A question.
Speaking of total bricking, that brings us to how the manufacturer actually attempts to patch these flaws.
The updates.
Yes, but before we get into the brutal irony of the update process, let me pause and remind you, yes, you listening right now, if a quote-unquote smart device has ever stranded you, drop a comment with your story below.
We read all of them.
We do. Hit that like button and make sure you are subscribed. It really helps the algorithm. Okay, let's look at the over-the-air update gamble.
Over-the-air, or OTA updates, revolutionized tech.
It did.
They allow manufacturers to push patches and fix unstable software without forcing the owner to visit a physical dealership. You wake up, and your device is simply better.
In theory, but looking at the system architecture for this vehicle, based on the specs, the update process is a massive.
It is highly demanding on the car.
The car will often attempt to download and heavily install gigabytes of software data overnight while parked in your garage.
And remember, an electric vehicle isn't just one single computer. It is a massive network of dozens of individual electronic control units, or ECUs. Updating them requires keeping the vehicle's internal network completely awake.
And the software aggressively keeps that network awake for hours on end.
Drawing power the whole time.
Exactly. All that background processing slowly drains the tiny traditional 12-volt lead-acid battery hiding under the front hood.
Which is just a brilliant piece of engineering irony.
It really is. It's so funny but painful. You walk out to your garage the next morning expecting a fully charged, freshly updated vehicle ready for your commute.
And what do you find?
You discover a completely dead 6,000-pound brick.
Yep.
And because the 12-volt battery is dead, the basic electrical functions fail. You cannot even physically open the electronic door.
The irony actually goes much deeper than that.
Oh, enlighten me.
To understand why modern electric vehicles still rely on old-school 12-volt lead-acid batteries, we have to look at safety regulation. The massive lithium-ion pack under the floor operates at a very high voltage, often 400 to 800 volts.
Which is lethal.
Highly lethal. So when the car is off, mechanical relays called contactors physically disconnect that high-voltage battery to render the chassis completely safe.
That makes perfect.
The only way to close those relays and start the car is with an isolated low-voltage system.
So when the OTA update drains the 12-volt battery overnight, the car literally lacks the power to ask the giant battery for power.
Exactly. It is a critical safety feature working as intended.
But failing the user.
Even if it results in a highly frustrating user experience, the system is designed to fail safe.
A safety feature that requires you to physically jumpstart a tiny battery just to wake up the high-voltage contactors.
Just like an old gas car.
And while the car is still plugged into the wall, mind you, because you can't physically unplug the heavy charging cable from the port without 12-volt power.
You are literally tethered to the wall.
Adding insult to injury. But let's say you manage to jumpstart it and the car is finally awake. You are immediately faced with the battery management system, or BMS.
The BMS is the absolute mastermind of any electric vehicle.
The brain behind the battery.
Its sole responsibility is protecting the delicate chemical balance of the liquid-cooled lithium-ion battery pack mounted under the floorboards.
And based on the user reports I'm looking at, this specific BMS is deeply pessimistic.
It is highly conservative.
It is programmed to be so overprotective that it actively degrades the daily driving experience. Frustrated owners have dubbed the digital range estimator the guessometer.
That term is painfully accurate because range estimation is an exercise in probabilistic engineering.
Guessing the future.
Right. The BMS is constantly analyzing your driving habits, the ambient temperature, and the electrical load to predict what you'll do. In this specific vehicle, the engineers prioritized battery longevity and extreme caution over predictable interface.
Extreme caution doesn't quite cover it. The algorithm outright penalizes the driver for using basic comfort features.
It reacts very strongly.
Let's say you are cruising down the highway. The guessometer shows an estimated 200 miles of range remaining.
Plenty of range.
It's a chilly morning, so you switch on the heated steering wheel and the driver's side seat heater.
Now, from a physics standpoint, those two features draw a very minimal amount of electrical current compared to the massive traction motors moving the vehicle.
Right. It's basically nothing. But the software panics anyway. It instantly slashes your estimated range down to 160 miles in the blink of an eye.
Just vanishes.
You lose 40 miles of estimated range just for wanting warm hands.
The logic behind that panic is actually quite fascinating if you look at the coding.
I am sure the code is brilliant, but the result is maddening.
The software is projecting a worst-case scenario. It assumes that if you turned on the seat heater, you are cold, which means you might also crank up the cabin's main resistive heater next.
Ah, anticipating my next move.
And resistive heaters do draw massive amounts of power, so the algorithm preemptively slashes the display to ensure you don't get stranded.
It is trying to protect me from my own potential future actions.
Exactly. It's a babysitter.
But this artificial drop creates a wave of unnecessary range anxiety. It forces you to constantly recalculate your road trip strategy on the fly.
Doing mental math on the highway.
You are sitting there doing complex math in your head, wondering if you need to pull over, all because the car made an aggressive assumption, which naturally brings us to the charging.
Where the thermal management system really takes over.
And it takes over with an absolute iron fist. The manufacturer claims up to 130 kilowatts of maximum charging power.
Which is a decent speed.
For a quick 30-minute top-up. Now, for a modern EV, that's already on the conservative side compared to competitors that pull 250 or more.
True, the architecture's a bit older.
But they still frame this as a relatively quick pit stop.
Because theoretically, sustaining a 130 kilowatt charge curve gets you back on the road efficiently.
But the reality of the plug tells a completely different story. The software limitations become glaringly obvious.
The throttling.
The aggressive thermal management software almost never allows the battery pack to reach that peak.
And again, to defend the engineering slightly, this is the BMS prioritizing self-preservation over user convenience.
Always protecting itself.
Direct current fast charging generates an immense amount of heat, which actively accelerates the degradation of lithium-ion cell chemistry over time.
But it is incredibly strong. Unless the ambient outside temperature is absolutely perfect and you are pulling up to the charger with exactly 10% battery remaining, you are not seeing those peaks.
The window is very narrow.
The internal sensors detect even a slight cell temperature increase and rapidly throttle the charging speed down to a painfully slow 60 or 70 kilowatts.
Think of it like a modern smartphone that refuses to fast charge past 80% to save battery life.
Yeah, but my phone isn't keeping me stuck at a gas station.
Fair point. The moment the vehicle's internal sensors detect heat, it pulls the plug on the power. It is mathematically optimizing for a 10-year battery lifespan, completely indifferent to the fact that you have somewhere to be today.
So your promised 30-minute pit stop turns into an agonizing hour-long wait.
And you just have to sit there.
You angrily wait, trapped at a charger, watching much cheaper electric cars pull up, charge incredibly fast, and leave before you even hit 80%.
It highlights a deep philosophical divide in automotive engineering right now.
Which is?
Do you build a car that serves the immediate desires of the driver? Or do you build a car that protects its own hardware from long-term degradation at the expense of the user experience?
Well, that extreme caution we see in the battery management perfectly bleeds into how the car handles driving itself.
The driver assistance features.
The software is fundamentally terrified of making a mistake, which brings us to the highly advertised ProPilot Assist 2.0.
This is a highly sophisticated piece of tech, I have to say.
On paper, absolutely.
It utilizes sensor fusion. It combines an incredibly complex array of front-facing radar modules, high-definition optical cameras, and ultrasonic parking sensors to virtually steer the car and maintain distance.
It is an engineering achievement right up until it encounters what owners ominously call the shadow threat.
Edge cases are the bane of machine vision.
This is where the software's caution crosses the line from annoying to genuinely dangerous.
Phantom braking.
Yes. You can be cruising smoothly at 70 miles per hour on a wide-open, completely empty interstate.
But optical cameras, unlike radar, rely entirely on interpreting light and contrast to understand the physical environment.
Exactly. So a dark shadow stretching across the road from a highway overpass heavily confuses the optical cameras.
It sees a stark contrast line.
The safety software violently commands the anti-lock braking system to perform an emergency stop.
It is a notorious edge case across many vehicles, relying heavily on vision-based driver assistance. The software misinterprets the high-contrast shadow as a physical, solid object blocking the road.
A brick wall made of shadows.
And because it is programmed to prioritize collision avoidance above literally all else, it hits the brakes.
It doesn't just tap the brakes, though. It forcefully throws you against your seatbelt.
Full emergency stop.
Going from 70 miles per hour to 0 on an empty highway creates a massive, deeply dangerous rear-end collision hazard for anyone driving behind you.
It is incredibly risky.
The software is so afraid of a phantom wall that it risks causing a very real accident. It's like having an incredibly nervous driving instructor ready to yank the handbrake at any second.
It raises a crucial point about the current limits of machine vision. The software lacks the human context to say, well, the sun is at a 45-degree angle. That's just a shadow from the bridge.
Right. A human knows that instantly.
The computer only sees a sudden drop in pixel brightness in its path and reacts according to its strict safety parameters. It intentionally chooses a false positive over a false negative.
It chooses to give the driver a heart attack, is what it chooses.
Essentially, yes.
But to wrap up this technical breakdown, I want to talk about something that is absurdly funny, but perfectly encapsulates the friction between hardware and software in this car.
Oh, the motorized console.
The motorized sliding center console.
Yes, a very unique interior feature. Instead of a fixed armrest, the entire center console is designed to electrically move forward and backward at the touch of a button.
To create more legroom, which sounds great.
It is a neat party trick.
But according to the data we are looking at, it frequently gets permanently stuck right in the middle of its track.
And this isn't a mechanical failure of the physical track or the motor burning out. It is, once again, a software issue.
The software simply forgets the physical calibration limits of the small electric actuator motor.
Digital amnesia.
Exactly. And the punchline to this technological marvel, it essentially traps your expensive smartphone deep inside the lower storage cubby because you cannot physically slide the console back to reach it.
It is the perfect microcosm of the entire vehicle, honestly.
A beautiful cage for your phone.
If we synthesize everything we have discussed today,
Right.
living with this specific vehicle is a constant daily battle against an incredibly beautiful but deeply flawed digital brain.
It really is a battle.
It is an architecture that constantly prioritizes self-preservation, whether that is preventing memory crashes, saving the battery cells from heat, or avoiding shadows over a smooth, predictable driver experience.
You are constantly fighting the car just to use the car. Legacy automakers are clearly learning software the hard way, and the early adopters are just paying to be beta testers.
That is the reality of the bleeding edge.
It is. Before we officially wrap up, for the final time today, if you made it this far, please make sure to subscribe to the channel, like the content, and leave a comment below to support these deep dives. We love digging into the data for you.
The transition to software-defined vehicles is forcing a massive shift in how these systems are coded.
Yeah.
The mechanical hardware is refined and ready, but the digital brains need to learn how to actually serve the driver rather than just protecting themselves from every possible edge case.
Which leaves you with a final, provocative thought to mull over. As our vehicles increasingly transform into roll-in computers, are we allowing the obsession with smart safety and hyper-conservative battery protection to completely override the fundamental joy and reliability of basic driving?
It is the ultimate question for the industry.
If a car's brain is too afraid to let you use a heater on a chilly morning or coast through a simple shadow without panicking and slamming on the brakes, who is really in the driver's seat? You or the software? Catch you on the next deep dive.